it means that it is only transferred from one object to another. So it also means if we will try to put it in a certain situation out of the demonstrations last time. Ibig sabihin, nung nag-charge ka pala ng object by rubbing a, let's say, balloon on someone's hair, you are not creating electrons. Okay? You are just allowing some of the electrons from the hair to be transferred into another object. But if you will look at it as a one system, it means that the number of electrons present in that system is still the same before and after. It's just that some of the electrons are transferred or they were moved to another object. Okay? So, are we clear with this concept? So, ibig sabihin, again, hindi nagke-create ng panibagong electrons. Ito ay nalilipat-lipat lang sa iba't ibang objects through different charging processes. Okay, so let's now move to the next part. The next part is just an additional information. So, in electrostatics, you have already mentioned this one. In electrostatics, we consider electron as a unit. Okay? So when we speak of electron, it means it contains certain amount of charge and we do not talk about it in fraction. So pag nagsabi tayong the transfer of electrons, we're talking about electrons in whole numbers. So hindi tayo pwedeng magsabing half of the electron or any other fraction related to that. So lagi siyang whole or one whole. Okay? So yun yung concept niya. So if that's the case, therefore, we can also say that each electron should contain a certain amount of charge. Okay? So, and the number of electrons in that particular object, halimbawa, 3 siya. Therefore, the charge of that object is the multiple of the charge of the electron. Okay? Now, what is the charge of an electron? A single electron has a charge of 1.602 times 10 raised to negative 19 Coulomb. So, yan yung charge ng bawat isang electron. Okay? Now, let's now proceed to the next part. Now, the next question would be, how do charges interact? Kapag parehas sila, they will repel each other. Either parehas positive, parehas negative. If they are opposite, they will attract each other. Now, bakit ganun? So the next question is, why do charges interact in that manner? Ano ba yung present sa kanila? Bakit sila lumalayo or lumalapit sa bawat isa? Okay, so we have from Astro, electrostatic force. Okay, we are, similar answer. Electrostatic force, okay. The other term for that is electric force. Okay, so electric force, and in some references, electrostatic force is the one responsible for the attraction and the repulsion of two charged bodies. Okay, and it means that it is the reason also for this type of interaction. Now, there are two different forces. Siyempre, depende kung ano yung naging behavior ng charges. When they are towards each other, we call it the attractive force. Kapag naman they are moving away from each other, it means that that is a repulsive force. Okay? So, now that we know that there is a force that exists between these two different charges, the next question would be, how do we measure the amount of force present in these two bodies? Okay? So, paano natin ngayon i-measure yung strength? Alam lang natin yung type of force because we know the law of attraction, di ba? Because according to law of attraction, same charges repel each other and opposite charges attract each other. But the next question is, paano natin ma-measure? Paano natin makukompute yung amount ng force na present sa kanila? So, ano na ang makakatulong sa atin? So, that will now be the purpose of our Coulomb's law. Okay? So, the answer to that question can be answered by this particular law. So, Coulomb's law is a law that simply states that electrical force between two charged objects is directly proportional to the product of the quantity of charge on the objects, but inversely proportional to the square of the separation distance between the two objects. So, parang pag i-describe mo siya, ang haba, ang daming detalye. Hindi madaling tandaan, right? So that's the use of our mathematical expression. So this particular statement can be just simplified by this equation, wherein Fe, or the electrical force, is just equal to the product of your Coulomb's constant, which is K, times Q1, or the charge of the first object, times Q2, the charge of the second object, all over the square of the distance between the two charges or two objects. So, yun na ngayon. So, as long as you know how to interpret the equation, you can cite the Coulomb's law. So, ano lang sinasabi niya? Kapag daw, ano yung implications niya, rather? So, kapag mas mataas yung amount ng charges mo, when you increase the amount of charge in a body or in between two bodies, therefore, you are to expect that the force will increase between them. Okay? So, pag mataas yung, linagay mo, kunwari, you increase it 10 times, therefore, you can also expect that the force between them will increase 10 times also. But the relationship of distance and the force is they are inverse square proportion, di ba? Kapag lumayo yung dalawang objects sa bawat isa or dalawang charged particles, we are to expect that the force will also decrease. Okay? Magdi-decrease siya. And the relationship is inverse square. Okay? So that is now what is Coulomb's law is about. So this is the example number 1. I have here a prepared solution for this. However, based on experience, mas madaling matutunan ang isang bagay when you practice it, right? So I want to show to you the step-by-step solution. So hindi ko nagagamitin yung prepared presentation. So that you can also see and we can gather some of the tips in answering this. So I will redirect you to a Jamboard. Ayan, which I will share to your class as well. Okay? I-share ko din naman ito dun sa natin, sa ating Google Classroom. So let's start with the first example. So in example number 1, I have here, suppose that 2-point charges, each with a charge of positive 1 nanocoulomb, are separated by a distance of 1 meter. Determine the magnitude of the electrical force of repulsion between them. So again, we are after the magnitude of repulsion between these two charged objects. So in getting the magnitude, the one that will help us is Coulomb's law. Right? So let's start. Ano ba yung mga given? The first step is to write the given so that you can already see ano ba yung mga kailangan kong bantayan. Okay? Ano ba yung mga kailangan kong i-convert kung meron man. Para hindi ako malito mamaya. So our notations will be Q1, Q2, Q1 for the first charge, Q2 for the second charge. In here, we have 2-point charges now, each with a charge of 1 nanocoulomb. So, ibig sabihin, parehas sila ng charge. So, we can just write 1 nanocoulomb, 1 nanocoulomb. Next, since we have here nano, so ito na ngayon, since gagamitin natin siya sa computation, it's a good practice that at the beginning of your problem solving, you can already convert the values para wag kang malito mamaya. So this is also equal to 1.0 times 10 raised to negative 9 coulomb. So this is 1.0 times 10 raised to negative 9 coulomb. Okay, next, aside from the charge, we also have a separation or a distance of 1 meter. So tingnan natin, ang meter ay nasa standard unit na siya. Therefore, hindi na natin siya kailangang i-convert. So this is now our meter. So what other given can we list? Wala na. Ito lang yung nasa context. Next is, let's have the unknown. Ano ba yung sinosolve natin dito? What are we looking for? It says here that it should be the magnitude of the electric force. So that's right, the magnitude of electric force. So Fe, yan, magnitude ng electric force natin. Next, we have formula. Ano ba yung mga formula? Or ano ba yung formula na gagamitin natin for this? We have Coulomb's law. So Coulomb's law states that Ft is just equal to K times Q1, Q2 all over R squared, where K is equal to 9 pala, 9 times 10 raised to 9 Newton meter square per Coulomb square. So let me just double check the values. 9 times 10 raised to 9 Newton meter square per Coulomb square. This is now the Coulomb's constant, the value of the Coulomb's constant. Okay, so what would be the next step after that? We can use the illustration, because in illustrating, that's the time we can understand it better. We can have a new perspective when we illustrate. So this would be the illustration. So we have here two positive charges, right? Positive, positive. This is Q1, this is Q2, and they are separated now by a distance. So this is 1 nanocoulomb, 1 nanocoulomb. They are separated by a distance of 1 meter. Now, before you even start solving, you can already predict the interaction of these two. So ano nga ulit yung type of force na nandito sa dalawa, nag-exist sa dalawang charges na ito? You have what type of force? Okay, electric force specifically, repulsive siya kasi pareha silang positive. So you can write or you can already identify the direction. The influence of the second charge on the first charge is it will move to the left. Kasi matutulak siya ni second charge. And on the other hand, the influence of the first charge on the second charge is it will move to the right. Nakuha? So that's their interaction. Because of the presence of these two charges, yan yung force na nag-exist sa kanila. Tinutulak nila yung bawat isa. Kaya, ang influence ni second charge kay first charge, it will be pushed to the left. And ang influence naman ni first charge kay second charge, it will be moved to the right. Okay? Now, if we want to be very specific and we want to compute for the magnitude of the individual charges, let's try to name each force that will be experienced by each charge. So, ibig sabihin, this force, we can label it, this is how we can label it, F2 on 1. Okay. So, in this format, explain ko lang ng konti kung ano yung ginawa ko yan. Okay, F2 on 1 means that this is the source or the one that exerts the force. Okay? And the last number that you will write, that is the one that experiences the force. So we call it the field point. Okay? So again, in using this particular, what we call this, subscript, the first one is where is the force coming from, and the last number that you will write is the receiver of the force. Kaya nga, ang ginamit natin dito ay force of 2 on 1. Charge 2 on charge 1. Right? So if that's the case, how do we now write the second one? Paano natin ito i-describe yung nasa right? This can be written as, so alisin ko lang to, force of 1 on 2. So yan, tama. Yung huli mong isusulat, yun yung nakaka-experience ng charge. Alright. So if we are to describe these two different forces, their direction is they are opposite. Right? Or they are towards opposite direction. Okay. So now let's continue. Let's compute first. We are interested in the magnitude of the force, right? Pwede natin siyang i-compute individually so that we can also generate some insights or slash generalization on the amount I will compute first, or we can compute first for F2 on 1. So this is equal to, based on our formula, K, Q1, Q2 all over R squared. So this will give us 9 times 10 raised to 9 Newton meter squared per Coulomb squared times the quantity. The first charge, ito ang titingnan natin. The one with standard unit. So the first quantity is 1.0 times 10 raised to negative 9 Coulomb. The other quantity is the same, 1 times 10 raised to negative 9 Coulomb. And we can divide it by the distance between them. which is 1.0 meter. Yan. So from this equation, ano kaya ang matitirang unit? Ano nga po ulit ang ilalagay as direction? Wala pa po tayong nilalagay as direction. So later, when we answer the magnitude, when we get the amount of the force, if you want to describe it as a vector, that's the time we can write the direction. Okay? Sige. So thank you for that question. So let's continue. So from this particular equation, let's now simplify. Sa tingin nyo, ano ba ang appropriate unit for force? It should be Newton, tama. So paano kami yan magiging Newton? So from here, we have 9 times 10 raised to 9 Newton meter square. Yung meter square, manggagaling siya dito. Okay? So canceled. Yung square, meters. Next is the square of the Coulomb. Yung square naman ng Coulomb, galing siya dito. Okay? So just take note that when we are after the magnitude, we are to get the absolute value of charges. So kung magnitude ang tinitingnan natin, we have to get or to use the absolute value. Because especially if there are negative charges. Kasi nga, we are only after the magnitude or the strength of the force. Then afterwards, we will go back to our illustration to analyze and indicate the direction. Okay? Sige, so from this value or from this particular equation, after evaluating it, what would be the value of the force of 2 on 1? You will get, so using your calculators, so sabay-sabay natin i-compute. 9 times 10 raised to 9 times the quantity. So tapos press the fraction. On the numerator, we have 1.0 times 10 raised to negative 9. So since parehas lang ang value nila, pwede mo siyang square. Pero kung hindi ka confident sa pwede mo rin ulitin yung term na 1.0 times 10 raised to negative 9. Then on the denominator, you will have 1.0 meter. Then you will just square it. Okay. Next, press equal. So ilan yung kakalabasan? Very good. This is 9 times 10 raised to negative 9. This is now in newtons. This is now the magnitude of the force that exists. Okay? F of 2 on 1. So, ginawa ko siyang red para lang, i-color red ko na to. Yan. Para ma-distinguish natin later. So, what is the direction? If we are interested on the direction of this particular force, go back to the illustration and check. Pasaan ba siya? You will right, left. Okay? Since it's going to the left because of the effect of the second force, second charge, so you indicate left. Now, let's move to the second force. F1 on 2. Ano kaya ang magiging value nito? F1 on 2 will just use the same The same values. So what do you think would be the value of F1 on 2? If you are not sure or if you are not confident, pwede mong ulitin. So isulat mo ulit yung mga values natin. 9 times Newton meter square per Coulomb square times the bracket which contains 1.0 times 10 raised to negative 9 Coulomb times, doble yan ito. 1.0 times 10 raised to negative 9 Coulomb divided by 1.0 meter square. So from that, you will realize na, okay, you will just end up with the same amount or value. Therefore, ilan na? Parehas lang. 9 times 10 raised to negative 9 newtons. However, ano yung pinagkaiba nila? What would now be the correct direction of F1 on 2? This should be very good. Dapat to the right siya. Okay? So this is now to the right. That's why kinukuha natin yung absolute value, because if we will use the signs, pwede tayong malito kung ano ba yung ibig sabihin ng sign, 'di ba? Kung positive ba siya because it's going to the left or to the right. So para wag tayong ma-confuse, let's just use the absolute value and refer on the illustration for our direction. Okay? So yun yung technique natin. We get the absolute value of the charges in computation. Then again, refer to the illustration for the direction. Okay? So this is now the F1 on 2. What can you say about the values of F2 on 1 and F1 on 2? What generalization can we give? regarding this value and this value. Ano masasabi niyo dyan? They are, sige, fast talk. They are equal or not equal? Okay, equal. So, they're just equal forces. However, according to your classmate, so may nabasa akong, nasa na ba yun? They are equal but opposite in direction. Okay? So, that's our generalization. Ibig sabihin, the force experienced by charge 1 from charge 2 is just the same in magnitude with the force experienced by charge 2 on charge 1. It's just that they are towards the opposite direction. Okay? So let's now move to the question. So tatanungin ko kayo, paano kapag I increase the amount of charge of Q2? Halimbawa, i-increase ko ang amount ni Q2. I make it higher. Can we still expect that F2 on 1 will be equal to F1 on 2? Sa tingin nyo, pag in-increase natin siya, sabihin ko, i-times 2 ko siya, gawin ko siyang 2 nanocoulomb. Can we still expect that F1 on 2 is equal to F2 on 1 in terms of their magnitude? So you have answers, no daw, no. Sige, para malaman natin yung answer dyan, so, i-try natin. Okay? So let's move to the next slide or to the next page of the Jamboard. So what would happen is, I will just try to increase the amount of the other one. And i-compare natin ngayon, ano na ba ang magiging values ng F1 on 2 at saka F2 on 3, F2 on 1. So this becomes 1 nanocoulomb and this becomes 2 nanocoulomb. In-increase natin yung isa. Again, ang question natin dito is F1 on 2 equal to F2 on 1? Or meron bang isa na mas nag-e-exert ng force kasi dun sa isa? Right? So this is our question. So let's proceed. So, ano ang ina-expect nating directions nila? Since they are both positive, it means parehas lang ang ina-expect natin. Repulsive pa rin. Ibig sabihin, we assign the left one to be directed towards the left. So this is F2 on 1. And the other one is directed to the right, F1 on 2. Ang tinatanong natin ay kung parehas ba sila ng magnitude or magkaiba. So, majority of the prediction, no doubt. So, yan ang titingnan natin. Let's solve for the first one. F2 on 1 becomes, okay, Q1, Q2 over R squared. So, the same ang distance nila ha. Ito ay 1 meter pa rin. It means this becomes 9 times 10 raised to 9 Newton meter square per Coulomb square times the quantity 1.0 times 10 raised to negative 9 Coulomb. The other one is 2.0 times 10 raised to negative 9 Coulomb. All over 1 meter square. This will give us ilan ang value niya. So, 9 times 10 raised to 9 times the quantity, we have 1 times 10 raised to negative 9. Yung isa, yung other term, is 2 times 10 raised to negative 9. All over 1 meter square. So, ilan makukuha nyo dyan na value? You will get ilan? What did you get? Ay, sorry. May may na-miss akong parenthesis. Alright, so, okay na. Ilan nakuha niyong value? The exponent, of course, you are expecting it to be higher than the previous answer because we have multiplied it by 2. So, nung pag-multiply natin ng 2, maapektuhan si coefficient, di ba? So, magiging na siya 1.8 times 10 raised to negative 8. So, this is now in newtons. And if you will refer on the illustration, it is towards left. Next, how about the second So if this is the F2 on 1, how about the value of F1 on 2? Ilan ang magiging value niya? This because same lang, di ba? Parehas lang siya ng values involved. 1.0 times 10 raised to negative 9 coulomb, 2.0 times 10 raised to negative 9 coulomb, all over 1 meter square. Therefore, yan, same lang siya. So, ibig sabihin, anong correct answer? What is the correct answer to our question? When we increase the charge of the other charge, what happens to the force between them? Meron bang nagiging mas lamang, mas malakas yung attraction, or parehas lang sila ng ibinibigay na force sa bawat isa? Okay, so that's correct. It is still the same. We can still say that the magnitude of the force of the charges are equal, regardless of the amount of charge of the individual charges. Okay? So, yan yung nangyayari. Yan yung concept ng forces. Kahit sino pa man ang mas maraming binibigay, dapat parehas lang kayo ng na-experience. Okay? So, kahit na mas malaki yung amount ng charge. Okay? Parity of force on both charge. So, they will just have the same equal amount of charge. Hindi ibig sabihin na mas mataas ang charge mo, mas malaki yung force na may experience mo. No. It's parang give and take. Okay? So, dapat equal kayo ng ma-experience na force regardless of the amount of charge that you contain. Okay? So, that's the concept of our charges. Pero kung i-compare natin yung amount of force na nag-exist in the first and second setup, yun yung nag-increase. Diba? If we compare it on our previous setup, ito, wala pa siyang ang value niya lang na nag-exist sa kanilang dalawa ay 9 times 10 raised to negative 9. Pero dun sa second setup natin, nung in-increase natin ang value nung isa, ginawa natin 2 nanocoulomb, doon natin na pansin na nag-increase yung force na na-experience nila together, not individual. Okay? So, yun yung ating concept of Coulomb's law. Na kahit magkaiba yung charges nila, same force will be experienced by the charges involved. Okay? So, that's right. Next, let's now move to the next example. Okay na ba? Nagets nyo na? Habang tumatagal, mas padali na siya ng padali. You will get used to the symbols, you will get used to the signs. Okay? So, one more example. So, this time, let's move to the second one. So, what is the electric force between an electron and a proton that are 1 centimeter apart? Use proton's charge. Positive 1.60 times 10 raised to negative 9 coulomb. So, this time, electrons and protons naman daw. Ilan ba yung force na nag-exist sa kanila? So, let's compute na lang for the individual charges, kagaya ng kanina. Okay, let's start. Again, first step is to write the given. The given, so, dapat, black yung that. Yeah. So, let's start with the charge of the first one, which is the electron. So, we know that this is negative 1.6 times 10 raised to negative 19 coulomb. However, please take note that we will use the absolute value. Next, Q2, we have, ito naman positive, so walang problema. 1.6 times 10 raised to negative 19 coulomb. But still, we have to use their absolute value. This time, we have in our distance, R dapat yung aking notation. Sabi dyan, 1 centimeter. Is it on the standard unit? Hindi pa. Ilan ang equivalent niya if we will use meters? So, 1 centimeter is equal to blank meter. Okay, so ang centi, it's 10 raised to negative 2. So, if we use the standard form, you will arrive with 0.01 meter. Okay, next. How about the unknown? So, ang unknown natin dito, ang pinapahanap lang talaga dito ay FE. However, we want to be more specific. So, ang gagamitin natin ay F2 on 1 at saka F1 on 2. But generally, since we know that they are just equal, right? Generally, they are referred as FE or the electric force. So, let's now move to the formula. So for our formula, we know that Ft is just equal to K times Q1, Q2 all over R squared. For our illustration, magkaiba sila ng charge. The other one is positive and the other one is negative. So in this particular example, sabi niya ano daw, 0.01 meter ang kanilang distance. So what is now the effect of charge 2 on charge 1? Ano na yung kind of force na nag-exist between these two? Since they are opposite, right? Iba na yung kanilang charges, that there will be an attractive force. So ang effect ngayon ni charge 2 kay charge 1 ay papunta sa ang direction dapat. It will be the effect of charge F2 on 1, it is directed to the right. Very good. And the effect of the other charge is to the left. F1 on 2. Okay, so let's now solve for the individual magnitude. Since alam natin na parehas lang sila, kasi nga based on our previous experience, we were able to generate the generalization that they will just be equal. F2 on 1, it will just be equal to the magnitude of F1 on 2. Therefore, F2 on 1 is equal to 9 times 10 raised to 9 Newton meter square per Coulomb square times the quantity. Absolute value po ang gagamitin natin, negative 1.6 times 10 raised to negative 19 Coulomb. And the other one is absolute value of positive 1.6 times 10 raised to negative 19. Ayan, hindi na kasya. Liit-liitan ko lang konti. So we have, dahil hindi siya kasya, 10 raised to negative 19. Ayan. Tapos yung isa ay negative 1.6 times 10 raised to negative 19 Coulomb. So parehas sila in Coulomb. All over 0.01 meter. Ilan ang magiging value ng ating F2 on 1? Therefore, you will get ilan dyan? 9 times 10 raised to 9 times the quantity. Numerator natin ay 1.6 times 10 raised to negative 9. Since naka-ano lang siya, naka-absolute value, parehas lang ang value, we can just square it. Divided by 0.0, ilan? 2.304 times 10 raised to negative 4. This is now in newtons. Parehas ba nakuha natin values? Parehas lang? Did you get the same amount? Sorry, 19 pala. Sorry, may error po ito. 9 po yung nailagay ko. Sorry, may error to. Wait lang. 24 pala. 24. Kaya pala walang nag-a-agree. So you can tell me if I write something wrong. Okay? So this is now the value of F2 on 1. Kindly check. Pasaang ano. Okay na tayo? Parehas ang value na nakuha nyo? Is that a yes? Okay. So, saan siya? F2 on 1. So, we can say that it is towards right. Yung F1 on 2 naman, the same amount or the same magnitude. However, we can say that this is towards left. Okay, so, ayan na ang ating final answers. F2 on 1, this is now F1 on 2, itong color red. F2 on 1, the color. Ayan. Okay? Kuha? Nagets na? On our next example, kung okay na kayo dito, if we will have an example for 3 charges. Di ba ito mga previous examples natin? Ano pa lang, dalawa. Okay, paano naman kapag 3 charges na? So, kagaya ng next example natin. Sige, so before we start with our next example, 2 minutes break for you to absorb everything. So if you are still processing this, okay, 2 minutes. Let's go back at 10:10 to continue with the last example. Okay? Then kapag may na-realize kayong question, i-chat nyo lang. Okay, so at this point, we are now down to our last example. Ma'am, palagi po bang naka-absolute value ang Q? The answer to this is yes, if we are speaking of magnitude. Kasi ang ina-avoid natin na maging problema ay pag-assign, ang sign ng ating force, di ba, in our vector discussion, the sign of the force indicates direction. Okay? However, in this particular context, sometimes the direction, our convention is positive siya pag to the right, tapos negative siya to the left. There are instances na pag ginamit mo yung sign ng particles, pwedeng ma-confuse ka sa direction ng charges kasi magkaiba yung nasa value at saka dun sa pag i-refer mo siya sa illustration. So to avoid that kind of confusion, we just use the absolute value for the magnitude to determine the strength and refer on the illustration on what should be the proper direction of the force. Okay? Okay na? Aliyah, sige. So let's now continue with our last example. So this, again, example involves 3 different point charges. Ay, 3 na siya. And again, if you already know the concept, magigets nyo na to. Or magiging simple na lang siya para sa inyo, kahit na nagkaroon ng additional charge. Okay? Sige, so let's proceed with our example number 3. So this time, 2-point charges are located on x-axis of a coordinate system. So, illustrate muna natin. Ay, gamit ako ng color black. So, if this is our, ayan, x and y. So, anong sunod na given dyan? Ang coordinates daw ni charge number 1. So, we have 0. Nasa 2 cm siya sa x-axis. So, we have 1, 2. So, charge 1 is here. Q1 is positive, 1 nanocoulomb. Okay? Next, si Q2 naman, ay nasa, again, in centimeter po ang ating units. This should be in centimeter. Si Q2 naman ay nasa positive 4 centimeter. 1, 2. So, nandito siya. Positive 4. However, if you will take note of the charge, the first charge is positive. Saan yan ang galing? Dito sa charge niya. Positive ito. The second charge is negative. Yan, Q2 is negative. So, ilagay mo yung sign niya. And the amount of Q2 is negative 3 nanocoulomb. Okay. Lastly, for the last charge, it is located on the origin. Okay, charge 3 is on the origin. And it is, or it contains positive charge. So, positive siya ulit. And this time, ang amount niya ay 5 nanocoulombs. Now, the question here is, what is the total electric force exerted by Q1 and 2 to the third charge? Diba, pag natin, nung nag-discuss tayo ng vectors, we are, if there are 2 different vectors involved, we are to get their sum. Okay, we are adding vectors in order to arrive to the resultant vector. Parang ganito rin yung concept ng superposition of forces or electrical forces. You will see whether to which direction are the forces influencing the charge, saang direction ba sila papunta? Ano ba yung strength ng mga forces na yun? Then we add them together. Okay? So since lang naman to, two-dimensional, one-dimensional. So madali lang siya, mag-a-add ka lang. Okay? Mag-a-add ka lang ng vectors natin. Kung positive siya or negative. Again, positive is for towards the right, negative siya pag towards the left. So it means that there are 2 forces involved. First is, ano yung nagiging effect ni Q1 kay Q3? Pasaan siya? What is the effect of Q1 on Q3? Since they are both positive. So ano yung F1 on 3? To which direction will it go? F1 on 3. Pasaan? It will be, anong effect nito? Q1 kay Q3. Repulsive. Correct. So, ina-analyze natin yung nagiging effect ni Q1 and 2 kay 3. Yun yung problem dito. Okay? So, kung repulsive siya, therefore, papunta nga sa left. Ayan. So, F Q1 on 3 is towards left. F1 on 3. How about the second charge? F2 on 3. F2 on 3. Pasaan siya? F2 on 3 is what type of force and pasaang direction? Si 3, kung ang magbibigay or mag-exert ng force ay si charge number 2, which is this. What will be its effect on Q3? Okay, attractive and to the right. Attractive and to the right. So if you can see, magkaiba ngayon yung direction ng force na na-experience ni Q3 kay Q2, tsaka Q3 kay Q1. So in this situation, ang focus or ang bida dito ay si Q3. Tapos para lang siyang may dalawang friend. Dalawang friend na si Q1 at si Q2, magkaiba yung sinasabi sa kanya. Okay? Si Q1 sabi sa kanya, "Uy, pumunta ka sa left." Si Q2 naman sabi sa kanya, "Uy, pumunta ka sa right." So ang tanong, sino ang mas may influence? Sino ang mas malakas ang influence kay Q2? Is it the first charge or the second charge? Yun yung pinakatanong dito. Okay? So in order for us to find out, so let's try to compute for the individual amount of charge. So for us to get the F net, so the F net here is equal to the F3. Okay? Yung force na nakaka-apekto kay F3 ay equal siya sa sum ni F1 on 3 plus F2 on 3. Okay? Nakuha? So if that's the case, therefore, we have to compute individually for the value of F1 on 3 and F2 on 3. So let's start with F1 on 3. So F1 on 3 is equal to K times Q1, Q3 all over R squared. K is 9 times 10 raised to positive 9 Newton meter square per Coulomb square times the quantity. Okay, ang quantity natin ay, again, this is in nano, hindi pala natin nasulat yung mga given. So 1.0 times 10 raised to negative 9 Coulomb. And the charge of Q3 is positive also. So 5 times 10 raised to negative 9 Coulomb. All over, ilan ngayon yung distance nila? Since sabi natin that in centimeter ito, tapos based on the situation, meron kang 2 centimeters. So 2 centimeters have to be converted to the standard unit. So dapat, tama, 0.02 meters. Ito ngayon yung gagamitin mo as denominator. So let's now compute for the value. Therefore, F1 on 3 will be equal to 9 times 10 raised to 9. Sige, solve tayo. 9 times 10 raised to 9 times the quantity. The first charge is 1 times 10 raised to negative 9 times, again, 5 times 10 raised to negative 9. So for our denominator, we have 0.02 squared. And you will get 1.125 times 10 raised to negative 4. So I hope parehas tayo ng nakuhang value. Okay? Refer on the illustration. Pasaan siya? To the left. Ibig sabihin, if this is to the left and we want to indicate it as a vector, that's the time na maglalagay tayo na negative value. This is negative. Again, this means that this is towards left. Okay? How about the second value of the force? F2 on 3. This time, it's a negative value. Pero again, we use the absolute for the magnitude. So, we will have 9 times 10 raised to 9 Newton meter square per Coulomb square times the quantity. Ang 2 ay negative 3, pero again, we use the absolute value. Negative 3 times 10 raised to negative 9 coulomb times the quantity 5 times 10 raised to negative 9 coulomb. Okay? And divided by, how about the distance between Q3 and Q2? Gaano na sila kalayo sa bawat isa? Parehas lang ba ng previous value natin? Or this is relatively farther from Q3? Mas malayo siya, no? Because we have 1, 2, 3, 4. 4 units away from our Q3. Therefore, ilan na na-expect natin na value dito? Their distance from each other is 0.04 meters. Okay, so let's simplify. Ilan na yung magiging value niya dyan? Palitan mo lang kung hindi mo pa na-erase yung kanina. So you have 9 times 10 raised to 9 times, the first charge is 3. Magiging 3 na siya. 3 times 10 raised to negative 9. Tapos yung second charge, parehas lang, which is still 5. On our denominator, papalitan mo lang ng 0.04 squared. So you will get 8.47 times 10 raised to negative 5. So since it's to the right, ano mangyayari? Positive siya because it is to the right. Okay, nakuha ba ang ating concept? Now, from our answer, ito na yung answer natin ngayon. Let's go back to the main question. Ilan daw ang F-net or ilan daw ang value ng F3? If we are to substitute the value of individual forces, sige nga, we tried solving for F3. F3 now becomes, i-continue ko ba dito, i-move ko na lang siguro. F3 is equal to negative 1.125 times 10 raised to negative 4 newtons plus 8.34, ay balik ko, 8.437 times 10 raised to negative 5 newtons. Therefore, F3 becomes, anong final answer natin dito? Negative. So your answer, 8.37, mag-subtract ka ng 1.125 times 10 raised to negative 4. You are to get negative 2.81 times 10 raised to negative 5 meters. Okay? So we have the same answer, Arvin. From this answer, which do you think has a greater influence kay Q3? Si Q1 or si Q2 ang mas nakapagbigay ng greater influence sa kanya? Yung final answer natin ay negative 2.81, which means the magnitude of the force is 2.81 and the direction is to the left. Therefore, which one gave a greater influence on Q3? Yan, correct. It's the first charge, which is Q1. But if you will notice, although Q2 has a greater amount of charge, what factor could have affected why Q1 is still a greater influence to Q3? Kahit na mas mataas yung charge ni Q2. Yan, the distance. So, ibig sabihin, matindi pa rin talaga yung effect ng distance, no? Kaya siguro madaming nagbe-break apart, di ba? LDR. Ginawang charges yung tao. Okay, so the distance has really a great effect on the force experienced by the charges. Alright? So, are we clear with this process? Nakuha? When you encounter the same concept, okay na? You can, okay, very good. So, at this point, siguro mga paalala lang, mga kailangan tandaan. First is to double check the units. Nasa standard units na ba siya? If not, you have to convert. Second, your illustration will be very useful in predicting the correct answer as well as double checking, to double check or to verify whether your answer is indeed correct. Next, just in case nahirapan kayo, your step-by-step process, take it slowly but surely. So, to avoid confusion or to avoid parang nag-mix up yung answers, no? Or nalilito kayo. And lastly, you always have to go back to the concept in order to arrive with it with the correct answer. So at this point, we will now end the session. So I'm now generating the attendance through the online tracker or to the attendance tracker. Okay, so I have successfully extracted it. Ma'am, in describing direction po, gagamit po ba kami ng negative or positive sign? Oo. So that's the expectation, the positive and negative sign, if ever ang hinahanap sa inyo ay magnitude and direction. Kaya nung start, hindi ko muna siya in-introduce so that I can break the concept gently. Hindi kayo mabigla. Okay? But on our future examples, you can now use the positive and negative sign. Alright? Sige, so let's end this session. So thank you everyone. Please feel free to leave the session. I'll see you again next time.